Hi, my name is Paul. I will show the code I wrote for this project. Basically, we were asked to write a code for the functions load data and get model. And it's quite simple. Just we can read the code, and it's quite simple. Yeah, the main part is this. I am which read the image as an MPG array, which is we're asked to. Then we check the dimensions. It normally has 3 dimensions: width, height, and the number 3 means that there are three data for each component of the array, and then we need to resize to 30. As we can see here, the width and height for the resized image is 30 and 30. So we do that. So then we convert from BGR to RGB, which is expected by TensorFlow now, and we can see that we have the images and the labels, and we will return a tuple images dot comma labels. Get model. At the end, I had 2 convolutional layers, convolutional layer 1 and 2, which has convolutional 2D and max pooling 2D. I tested several hyperparameters to try to find which is the best for our case and for our data. Then we apply the flattened and then the hidden layers. I chose to use 2 hidden layers because the output, the accuracy was better, and use a dropout to avoid overfitting. And finally, one output for each category. Then we compile a model using the item optimizer, the categorical entropy loss, and the accuracy metrics, and it will return the model, which then it will be used for this part of the code that we were not asked to modify. But that's all the magic. I will delete this previously saved model, and then I will run the code. Python traffic.py gtrb and model a5. Let me see, it's running. We have 10 epochs, so we are in the number 4 of 10. And we are about to finish. And as you can see, the final accuracy was a very good one, near to .94. So the model.h5 was created here. Then we were asked to create a README file where we can describe what we were doing, so you can read it and it's easy to understand. So basically we tested several hyperparameters and the number of layers and convolutional and max poly layers. I tried also the average pooling, but it didn't work to find, so I prefer to use max pooling 2D. Then I have I created this file to test the features we were asked to write. So I will run this quickly, and then data, to use log data here. So we see it will wait. So we see images is a list of arrays which contains all the images and the labels. And then for consistency we check the length of both arrays, or both lists, sorry, and they match. And then we do the split data and check the length also of the list. So okay, so there is correspondence. Then we compile the model again. Then we feed the model and we make a pause, and we are here again. The accuracy is very high, and then we do the evaluate of the model, the evaluation of the model, and we get an accuracy near to 0.95, and then we test the model saving into a file. .h5 is standard now for these models, when it saves in one single file that can be loaded by other applications. So you see, I created a model 3.h5. It's a single file, can be read normally but can be loaded. Then I created another file to test the code. So I put some images, own images, with blurred images of some traffic signs, so in order to be detected, predicted by our model. That's it. This just use the model .h5 that we produce with our code, and then we process all these images, single images, and use the prediction capabilities for the model. So then it will predict the class for each image under the on images folder. Let's run it. You will see for image 1 predicts a class, it predicts a class 17, for image 2 class 2, and for example I can remember now that the class 14 corresponds to a stop sign, so it's going okay. So that's all I can show you now.